In this video, we are going to discuss Class 11 Mathematics Chapter 1 Sets Introduction to Exercise 1.4. In this, we will discuss the concepts and formula required to solve the problems of Exercise 1.4. See the link below in the description box for the previous videos on sets. We learned in the previous classes how to represent the sets. There are two ways, roster or tabular form and set builder form. Now we'll see visual representation of mathematical sets. How to represent the sets, then their relationship pictorially. That means through a diagram. This is invented by English logician John Venn. It is named after him. These diagrams consist of rectangles and circles. The universal set is represented usually by a rectangle, and its subsets are by circles. The elements of the sets are written in their respective circles. Let us see an example. In this example, universal set is having the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have represented this universal set in a rectangle. You can see it here. This is, you have written U here. That means this is a rectangle and universal set is written here, and the elements should be written inside the rectangle. Now we have two sets, subsets of this universal set. Set A consists of 1, 2, 3 elements, and set B consists of 4, 5, 6. These sets are represented in circles. As you see, set A is having 1, 2, 3 elements, and set B is having 4, 5, 6. The remaining elements 7, 8, 9, 10 are outside these circles but within the rectangle. 7, 8, 9, 10. You can see them. This is how you represent the elements of sets. Once again, I repeat, the universal set is represented by a rectangle, and the subsets of it are represented by circles. The elements are written inside them. We'll take another example. This here, another universal set. It is 1 to 9. Two sets are there. Subsets A 1, 3, 5, 7 and B 5, 7. These 1, 3, 5, 7 also present in this universal set. 5, 7 also present in this universal set. Did you observe the 5, 7 also present in this subset A? So how do you represent this in Venn diagram? As first, we will draw the rectangle to represent the universal set. In that, you have to write all the elements. In this context, what we will do is, first we will write the smallest set. What is this? B. This consists of 5 and 7 elements. Because 5 and 7 elements are present in A also, this B is having 5 and 7, and the set A is having 1, 3, 5, 7. We are having a circle outside this B. We are writing the elements 1, 3, 5, 7. 5, 7 is already written inside, so 1 and 3 are written inside this circle. So circle B is having 5 and 7. Circle A is having 1, 3, 5, 7. The remaining elements are 2, 4, 6, 8, 9. They are written in the rectangular box to represent the universal set. This is how you represent a universal set through Venn diagram. Now we'll see some operations on sets. First one is union of sets. See, let A and B be any two sets. Here A is one set, a circle, and B is another set. They are both are the subsets of this universal set. The union of A and B is the set which consists of all the elements of A and B put together. The common elements are written only once. Symbolically, we write this A union B and usually read as A union B. Okay, let's take an example. A is a set with 1, 2, 3, 4, 5, 6 as its elements. Set B is another set with 5, 6, 7, 8, 9, 10 as its elements. If you observe, 5, 6 are common to both sets. How do you represent these sets in the Venn diagram? You can see 5, 6 and common. If you take A union B, you will write 1, 2, 3, 4, 5, 6 and 5, 6 of this B will not be repeated. Common elements are written only once. So 7, 8, 9, 10. This completes the A union B. So pictorially you can see A is this one and B is this one, and the common area here is as it is these two circles are intersecting. The two sets are intersecting. The common area is written here and the common elements are, the common area is consisting of the common elements 5 and 6. So A union B is, I am hatching down, this is this entire area is A union B. This is the common area. We will see the properties of the operation of union. As you studied in your previous classes, in the addition, subtraction, for them some properties are there. These are the commutative property, associative law, and law of identity. See, commutative property means, see in the simple addition, what is 3 plus 4 also equals to 4 plus 3. That means A plus B equals to B plus A. Similarly, this commutative law is applicable to operations of union. A union B is what? The complete number of elements of put A and B put together. If you are adding the elements to elements of B to A or adding elements of A to B, doesn't make any difference. You are removing the common elements. The commutative law is applicable here. Second one is associative law. This you know very well. In your previous classes you have studied this. Similar to that, A union B within brackets union C is A union B union C. This is also applicable to this. Next one is A union phi. A equals to A. This law is called law of identity element. Phi is the identity of U. Because A is a set and phi is another set with no element in that. If add that set to A, it becomes what? then it becomes set A only because no additional elements are added to it. Second, this one, fourth law is A union A. Means you are adding a set to itself. That means all the elements of A added to A and the common elements anyway you are removing them. So the original elements are left with the set. So it becomes only A. This is idempotent law. Last one is law of universal set. Universal set union of A equals to A is, remember, A is a subset of universal set. We are considering always a universal set. Means remaining all the sets are subsets of that universal set. So now U E union of A means universal set and you are adding the subset. Anyway, that subset means that the duplicate elements are removed. You are left with the universal set. So U union A equals to U. Now the other operation is intersection of sets. Intersection of sets means we'll say, let us see, we'll set A and set B as there. The set of all elements which belong to both A and B is called the intersection of the sets. We'll use the symbol, this, we see the symbol, the intersection symbol is used to denote the intersection. Symbolically, we write A intersection B equals X such that X belongs to A and X belongs to B. That means X belongs to both A and B. Let us take an example. A equals to 1, 2, 3, 4, 5, 6. B equals to 5, 6, 7, 8, 9. As you observe, 5, 6 are common here. So this is the intersection of A in B. We can write A intersection B is equal to 5, 6. So we understood what is a union, what is an intersection. What is the A union B? This is 1, 2, 3, 4, 5, 6. Removing the common elements, 7, 8, 9, 10. What is A intersection B? You have to take only the common elements, 5 and 6. Let us see another example. A is 1, 2. B is 3, 4. What is A union B? Simply you have to add all the elements 1, 2 and elements of B 3, 4. No common elements. What is A intersection B? What are the common elements in this? Null, nothing. So this is a null set. Disjoint sets. We have discussed just before in the previous example. A and B are two sets when such that A intersection B is 5, then A and B are called disjoint sets. That means they don't have any common element. A intersection B is a null set. In the Venn diagram, we'll represent them like this. You see, this is set with 1, 3, 5, 7 and this is another set B with 2, 4, 6, 8. They are not intersecting each other. They are disjoint sets. We will see the properties of the operation B intersection A. It is commutative law. See, two sets are there, A and B. This 1, 2, this is 3, 4, this is 5, 6 and 8. This set B is having 3, 4, 5, 6, 8 as elements. This set A is having 1, 2, 3, 4 as element. What is A intersection B? 3, 4. We are intersecting A and B, taking the common elements of that, or B intersect A, 3, 4, 5, 6 and intersecting with 1 point, 1, 2, 3, 4. The same, you will get the same result. 3, 4 is the intersection point. 3, 4. That means A intersection B equals 3, 4. Agreed? Associative law. Similarly, A intersection B intersection of C is equal to A intersection of B intersection C. This is associative law. And then law of pi and U. Law of pi and U. Phi intersection A. That means if phi is intersecting with anything, that means no set is there, no element is there, and some elements are there. What is common in this term? No element is common. So the result is null set. The result is null set. And universal set. Complete all the elements are there and intersecting with A. This is very important. All the elements are there intersecting with A. A is a part of this thing. What are the common elements in this? Is A. So this is equal to A. Right? Idempotent law. A intersection A is what? Suppose A is there. What is intersection with A? That means it is completely overlapping with each other. Right? This overlapping with each other. So that is nothing but A again. Now distributive law. A intersection B union C equals to A intersecting B. This is union A intersecting C. This is what it means, distributive law. This is also true. In the next slide, I will prove this pictorially. See, this is B union C, right? This is what? B union C. We am taking three sets, A, B and C. All are a subset of a universal set. What is B union C? This is the B union C, right? This B and C together. And what is the intersection of B union C? B union C is this. And what is the intersection with A? What are common with A? This is A, right? This portion is this is A, right? This common to B union C and A. A and B union C. B union C is this and A is this. This is the portion. This area is A intersection B union C. You will have a lot of this type of problems in future. To focus on this. This concept is very much used in future Venn diagram problems. In the second one, see what is A intersection B? A intersection B is this one, right? What is A intersection C? This is the A intersection C. So this and this, what is union of that? This and this, right? That's what we are getting here. A union A intersection B union A intersection C is this portion. So this and this is same. Yes. So that is how you can pictorially we can prove that A intersection B union C is equal to A intersection B and union A intersection C. Now see the difference of sets. What is the difference of sets? Let us see. Two sets are there. A 1, 2, 3, 4, 5, 6. B 5, 6, 7, 8, 9, 10. What is the difference of set? Remove some A minus B. You wanted to write. This is the difference of sets. Difference of A minus B. See, A is what? 1, 2, 3, 4, 5. Remove all the elements of B from this A. What are the elements in the 5, 6, 7, 8, 9? A is what? 1, 2, 3, 4, 5, 6. Right? What are the elements in B? 5, 6, 7, 8, 9. Remove this element. 5 is there. Remove this. 6 is there. 7, 8, 9, 10 are not there. No need to remove. Means there is no need to remove. So what are the left out elements? 1, 2, 3, 4. This is A minus B. That is the difference of elements. What is B minus A? This is also a difference. We'll write all the elements of B. 5, 6, 7, 8, 9, 10. Subtracting the elements of A. 1, 2, 3, 4. They are not there. So you need to remove. But 5 and 6 are there. You have removed 5 and 6. So what is the result? So B minus A is what? 7, 8, 9, 10. Very good. Two differences. Difference of sets. It is this is this is the difference of sets. A minus B is this. B minus A is this. Did you observe? A minus B is not equal to B minus A. This is an important conclusion. A minus B is not equal to B minus A. Another example you can say AEIOU. Another example is this B is AAKU. What is B minus B? Simple. E and O. Since the elements E, O belong to V but not B, and B minus B, what is B minus V? B minus AIU. AIU you remove, left out is only K. This is the one. Also, B minus B is not equal to B minus B. Hope you understood the difference of sets. It's not very difficult, but you remember this, how to represent them in Venn diagrams. Now we have to, using the set builder notation, we can write the difference of sets. A minus B is equal to X such that X belongs to A and X does not belong to B. X belongs to A and X does not belong to A. A minus B such that X is such that this is the thing. The difference between two sets A and B are represented by Venn diagram as this one. This is very important. This is a universal set. One set is there. Suppose another set is there. What is the A minus B? this portion. This is A, this is B. Completely remove this B from the A, the chunk. The shaded portion is the A minus B. This is an important concept. A minus B, A intersection B and B minus A are mutually disjoint. I will show in the next slide. See, this is A, this is once A, set A, this is B. What is A minus B? This blue portion is A minus B, correct? What is B? What is B minus A? This red portion, that hatching, right? Agreed. What is A intersection B? This is the common portion. A common portion. Did you observe that? This. So, did you observe this? This A and this B. This red portion is B minus A and A blue portion is A minus B. And this in between, the green one is A intersection B. Three are mutually exclusive. No element is common to them, mutually exclusive. You can see. So, A minus B, A intersection B, B minus A are disjoint. That means mutually exclusive, you can write it, or they have no common element. Also, you can observe, put together, they will be A union B. Agreed? Put together, they join all the elements of A and B put together. That concludes this video. In this video, we discussed how to represent sets with Venn diagram and operation on sets, union of sets, intersection of sets, and their properties, and what are the definition of disjoint sets. Hope you understood the concepts and solutions well. Don't forget to watch introduction and solutions together for each exercise. Please like and subscribe and share with your classmates and friends to get all the videos of the channel. Thanks for watching. See you then.